In this one, I want to prove, given that JL and KM are the same, I want to prove that JK is congruent to LM. So 1 JL is congruent to KM. That's given. And I've got some segments here. I have no idea what to do. I have no idea where to start. What segments should I add up? So let me take a quick peek at my givens. It talks about JL and it talks about KM. So I have some segments that are broken up. And it talks about those two segments. So maybe it would be useful to write out the segment addition postulate here. So first thing is still always the givens. Then I'm going to check out my segment addition postulate. I'm going to see if I can do anything there. JK plus KL equals JL. And then I have, let me move that over. KL plus LM equals KM by my segment addition postulate. All right. So I've done my givens. I did my segment addition postulate. But I should go back because I'm kind of stuck now. I don't see any way to simplify this. Is there anything that I can substitute from my givens? Well, the only given statement I have is that JL and KM are equal. Let me see if I can find JL and KM. Okay, there's my JL and KM. And it doesn't matter which one you substitute or which one you switch out. I'm going to substitute out the JL. I'm going to change it, and instead of JL, I'm going to write KM. Now, I know that I can do that because JL and KM are the same. I probably shouldn't have these segment lines above those. Okay, so I did my segment addition postulate. I did my substitution. I need to check out, is there any way that I can simplify these equations? Well, what do I notice about these equations? They both have KL. That's kind of nice. They are both equal to KM. So these two expressions both equal the same thing. They both equal KM. Well, if they both equal the same thing, could you pause the video and write out an equation that you could use to condense this into one step? If they equal the same thing, then they must what? Well, they must equal each other. So JK plus KL, because that equals KM, and so does this other stuff, I can say that instead of KM, I could write that as KL plus LM. Now you could call that substitution. You could also make a case for calling that the transitive property if you want to say that, A equals KM and KM equals something else, then A equals C. So you could call that substitution. I would also accept transitive property. In my final step, I want to get JK and LM together. Well, I've got JK, I've got LM, but I need to get rid of this KL. Luckily, there's one on both sides. I can subtract that KL from both sides. In my final step, it tells me that they want it congruent, but I just have it equal. But I know that those mean the same thing. Right, That's kind of what the definition of congruent is. It means that they're equal. So I could say that JK is congruent to LM. Well, how do I know that? Because I just said they were equal. Well, that's really the definition of what it means to be congruent. Okay, so those are the segment addition proofs. I'm going to do some transitive property proofs on a different video. Check that one out, and I will see you soon.